A very good evening to all. I am Dr. Sanjeev Kumar Singh, working as a scientist engineer in Marine and Atmospheric Sciences Department at IIRS ISRO, Dehradun. Today I am going to talk a very interesting topic on tropical cyclone. I think most of the people may be aware about the tropical cyclone. Every year, you know that every year you faces some cyclone over our Indian Ocean. You almost every year you hear the news about the tropical cyclone whenever it forms over the Indian Ocean and approaches toward the Indian coast. You heard about you hear the news every year about the tropical cyclone when it forms over the Indian Ocean and going to hit the Indian mainland. So people are more curious about the where tropical cyclone is going to hit, and every time, every minute, the monitoring of the tropical cyclone is very crucial because the tropical cyclone is among the most severe weather system, which is very it causes a loss of life, property, and infrastructure damages. When tropical cyclone form, the question is when tropical cyclone form, where form, and how we can monitor. We will discuss in this coming slides in this presentation. Normally, I want to share some basics of the tropical cyclone, what is the season of the tropical cyclone form, because in our Indian region, we don't receive the tropical cyclone throughout the year. There is a particular season. Basically, in India, there is a two period for tropical cyclone formations. One is the pre-monsoon and another one is the post-monsoon season. Pre-monsoon season is mainly about the April to June, and the post-monsoon season is start from October to December. Every year, on an average, 4 to 5 cyclone form over the North Indian Ocean and hit the Indian coast. You all are knowing about that our Indian coastline is so long, around 7,500 kilometers, and density of the population are also so high. So therefore, it becomes very important to monitor continuously and predict the tropical cyclone very accurately with the time. So in this presentation, we will discuss some basics about the tropical cyclone and how the satellite observations can be used for tropical cyclone monitoring and prediction. So now coming to my first slide. What is the tropical cyclone? First question is, what is tropical cyclone? How we can define the tropical cyclone? If you want to define the tropical cyclone in one sentence, you can define the tropical cyclone is warm core, a low pressure system, synoptic scale phenomena with organized deep convection which form over the warm ocean. Synoptic scale is basically the order of few 100 kilometer to 1,000 kilometer. So it is also known as the large scale phenomena. So tropical cyclone is not a few kilometer phenomena. It can extend up to 1,000 kilometer. So it is well organized convection system. It can extend in a horizontal scale 100 to 1,000 kilometer, and also it can extend up to 10 to 12 kilometer in the atmosphere, in troposphere, because you know that our atmosphere is categorized in different layer like troposphere, stratosphere, mesosphere. So in the troposphere, it can extend up to 10 to 12 kilometer. The main property of the tropical cyclone is the anti-clockwise rotating wind at surface and clockwise at upper level. So Our atmosphere is divided in different pressure level. Like if you go at a higher altitude, your pressure start decreasing. At surface, pressure is high. So you can divide atmosphere in different pressure level. So at the surface level, the wind is anti-clockwise. You can see in this picture, the surface wind is anti-clockwise rotating wind in the tropical cyclone. But if you go at the upper level means if you go at 10 to 12 kilometer in the atmosphere at height of 10 to 12 kilometer, you can see the wind is diverging, means there is a divergent kind of pattern you can see in the wind structure. So the basic property of the tropical cyclone is the at surface is anti-clockwise and at upper level is the clockwise rotating wind. Anti-clockwise also you can define, means you can define that wind is converging at some point and upper level it is diverging. So this phenomena is valid for northern hemisphere where we lies. Okay, north of the equator. Northern hemisphere is north of the equator, southern hemisphere is the south of the equator. So it is the anti-clockwise rotating property is valid in a northern hemisphere. But if you go in the southern hemisphere, this property is opposite. So in the southern hemisphere at the surface, the wind rotation is clockwise and upper level it is anti-clockwise. So it is just opposite. Also, you know that the tropical cyclone is associated with high winds, wind speed, high heavy rain, and storm surge. And due to the storm surge and rain, there is the flood kind of condition happen when tropical cyclone hit the coast. So this is all about the basic information about the tropical cyclone. So as of till now, you have seen that the if any anti-clockwise rotating wind at the surface is the property of the tropical cyclone. My question is, can we call any anti-clockwise rotating wind is tropical cyclone? Answer is no. So we cannot tell any anti-clockwise rotating wind at surface is the cyclone. So for that, our regional meteorological agency IMD has set some criteria for the Indian region to classify, to categorize this system, this wind structure based on the wind speed to identify the different stages of the low pressure. So when the wind speed, you can see in this table, this category is defined by the IMD. So when the wind speed is the maximum sustained surface wind. That is also you can call as the intensity. When the wind speed at the surface, maximum sustained surface wind is less than 17 knots or 31 kilometer, if you convert this 17 knots, it will be equivalent to 31 kilometer per hour. Knots is written because it is used in all over the world. So for the uniformity, it is written in knots. If you want to convert into the meter per second, you have to multiply by 0.58 or 52 something. So you can convert this into the meter per second. So low pressure area we can define if the intensity is less than 17 knots, and correspondingly the pressure drop at the center is 1 HPA. Pressure drop means you can calculate what is the pressure at the center and what is the pressure outside the tropical cyclone and what is the difference between outside of the outside pressure and at the center of the pressure. So you can find out the pressure deficient. So pressure drop is almost 1 HPA. Then depression. Depression depression can be categorized when the wind speed is 17 to 27 knots. And if you convert into the kilometer, it will be 31 to 49 kilometer per hour. Deep depression further, when the wind intensity is increasing, the deep depression can be categorized as deep depression will be happen when the wind speed is 28 to 33 knots, and the correspondingly that pressure drop is 3 to 4.5 SPA. When the wind speed reaches up to the 34 to 47 knots, then only we call as the cyclonic storm. Further, when the wind speed start increasing or gradually increasing, it is categorized as the severe cyclonic storm, that is the 48 to 63 knots. When the wind speed is 48 to 63 knots, then we call as a severe cyclonic storm. Very severe cyclonic storm, when the wind speed is 64 to 89 knots, then we call the very severe cyclonic storm, and the pressure drop is at the center is 20.9 to 29.4 SPA. Further, it can be classified as the extremely severe cyclonic storm when the wind speed is 90 to 119 knots. And when the wind speed is greater than 120 knots, we can call as a super cyclonic storm. So these are the category to define the low pressure. So we cannot call any anti-clockwise rotating wind at the surface is a tropical cyclone. We can only call when the wind speed is 34 to 47 knots. And also you can see in this table, because tropical we used to call as a tropical cyclone, but the other region it is name is different from it at other region. So there is the regional name of the tropical cyclone. Over the Indian Ocean, it is called as the tropical cyclone. Over the Atlantic Ocean, we used to call as the hurricane. When the low pressure or cyclone form in the Western Pacific and South China Sea, it is called the typhoon. So these are the different name, but property is same. Tropical cyclone formation basin, where tropical cyclone form. Basically, there are 6 major basins where tropical cyclone form. First is the Western North Pacific Ocean. Western North Pacific Ocean is around 120 east to 180 degrees east, 5 degree north to 20 degree north. And this region is called as the Western North Pacific Ocean, where cyclone has formed. Eastern North Pacific Ocean, this region is called the Eastern North Pacific Ocean. That is the 90 degree west to 120 degree west, 5 degree north to 20 degree north. So this Eastern North Pacific region, mainly whatever cyclone form, that is called the typhoon. Southwest Pacific Ocean, this region is called the Southwest Pacific region, where 155 degrees to 180 degrees, 5 degrees south to 20 degrees south. So this region is called the Southwestern Pacific Ocean. North Atlantic Basin, this region is called the North Atlantic Basin. That is the 90 degree west to 20 degree west, 5 degree north to 25 degree north. And the Indian Ocean has divided into two parts. That is the North Indian Ocean and South Indian Ocean. North Indian Ocean is above the equator, that is the North Indian Ocean, and below the equator is the South Indian Ocean. So Indian Ocean, where we experiences the tropical cyclone that lies in the North Indian Ocean. So what is the annual frequency of the tropical cyclone over North Indian Ocean? So we have analyzed around 25 years the annual frequency of the tropical cyclone based on the IMD database. So we have plotted the data, the frequency of the tropical cyclone which formed during the period 1997 to 2021. We can see in this bar graph, you can see that there are on an average 4 to 5 tropical cyclones form in each year. However, we can see the slight increase in 2018 and 19 of the tropical cyclone formation and 1998. So otherwise, more or less, on an average, the tropical cyclone formation is 4 to 5 cyclone per year. If you studied, if you divide it into the Bay of Bengal and Arabian Sea region, where how many cyclone has formed in Bay of Bengal region and how many tropical cyclone has formed in Arabian Sea. So you can see in last 25 years, the number of tropical cyclone formations over the Bay of Bengal region is more as compared to the Arabian Sea, except in 2019. In 2019 is the year where the number of formation of the tropical cyclone over the Arabian Sea is more. Some of the study tells that the reason for the more number of tropical cyclone formation is the ocean heat content, which increases in this particular year of the Arabian Sea, which is responsible for the more number of tropical cyclone formation. You can also see the arrow mark. The arrow mark shows that there is no any tropical cyclone form in the Arabian Sea. Otherwise, more or less, if you see the overall picture, the number of formations of tropical cyclone over Bay of Bengal region is more as compared to the Arabian Sea. If you compute in percentage wise, you can see in the last 25 years that 64% tropical cyclone form over Bay of Bengal and 36% in the Arabian Sea. So 64% contributes the Bay of Bengal and 36% by the Arabian Sea. If you look at the last 10 years in 2012 to 2021, the percentage contribution of the Arabian Sea is slightly increased around 39%. This is because of only the number of more cyclone formations in 2019. Otherwise, you can see no any significant increase has been observed in other years. One of the another interesting thing is because we experiences 4 to 5 cyclone each year in the North Indian Ocean, the same number of deep depression and depression also form over the both the basin, but due to some certain conditions and some atmospheric condition, it did not develop into the tropical cyclone, because already we have seen that tropical cyclone, when the intensity reaches greater than 34 knots, then only we call the tropical cyclone. It means depression and deep depression means the intensity did not reach the threshold of the tropical cyclone. So it is only at the stage, it was only the stage of the depression and deep depression. So a similar number of depression and deep depression also form in each year. Here we have seen that the number of formation of the tropical cyclone over Bay of Bengal is more. Why tropical cyclone form more over the Bay of Bengal? The reason is because the more number of river drain into the Bay of Bengal region, and due to this the freshwater flux is more over the BOB region. And if the fresh water flux is more, the sea surface temperature will be high. And this is the one of the factor for more tropical cyclone formation in the Bay of Bengal as compared to the Arabian Sea. Another reason is in the Pacific Ocean, more number of in this region, the number of formation of the tropical cyclone is much higher as compared to the Indian Ocean, because the wind movement in the tropics is easterly. It wind moves from east to west. So when the any low pressure form over the Pacific Ocean, due to the easterly wind, sometimes it steered or it diverted, it moved toward the Indian Ocean. Due to the very thin landmass, you can see the landmass over this region is very thin. So it crosses the land and reaches into the Bay of Bengal. That also adds the number of the tropical cyclone formation in the Bay of Bengal region. Now we have done the trend analysis of the tropical cyclone last 25 years and last 10 years. So you can see the tropical cyclone formation is slightly increasing trend. It is showing slightly increasing trend in last 25 years. If you studied in different bases, Bay of Bengal and Arabian Sea, you can see the formation of the tropical cyclone over Bay of Bengal is almost constant. But if you see the Arabian Sea, there is a slight increasing trend. This is because of only the number of more cyclone in 2019. If you look at the last 10 years trend of the tropical cyclone formation over North Indian Ocean, you can see the formation of the tropical cyclone is slightly that increasing trend it is showing. Over Bay of Bengal is also shows the slight increasing, and Arabian Sea it is showing the increasing trend in last 10 years. So the formation of the tropical cyclone is more, or it start increasing over the year. Now coming to the category wise, means there is so different category: low pressure, depression, deep depression, severe cyclone, very severe cyclone. So we have studied the trend analysis also. So we want to know which type of the tropical cyclone forms more nowadays. So we have studied last 10 years the tropical cyclone, the category of cyclonic storm is almost constant, constant. But the severe cyclonic storm, the formation of the severe cyclonic storm is showing the increasing trend. If you look at the very severe cyclonic storm, it is showing the increasing trend. Extremely severe cyclonic storm, it also shows the increasing trend. And super cyclone, if you look at the super cyclonic storm in last 10 years, you can see only two super cyclone has formed in last 10 years. One is 2019 and another is 2020. One name was the Kyar, and in 2020 the name was the Amphan cyclone. Amphan cyclone has formed over the Bay of Bengal and it hit the coast of West Bengal. If you look at the last 25 years, there are 4 super cyclone has formed. In 1999, one super cyclone was formed, which is called as the Odisha super cyclone. That was the most devastating cyclone, which was the responsible for more than 10,000 human life has gone in there due to this tropical cyclone. And the second number of super cyclone has formed in 2007 and 2 in 2019 and 2020. Now the question is what is the favorable condition? Because we have seen the previous slide that 4 to 5 Depression and deep depression also form each year, but it doesn't convert it into the tropical cyclone because of the some atmospheric and oceanic condition. For the tropical cyclone formations, there are some necessary conditions. Whatever conditions we have listed here, that is the only necessary. It is not sufficient. The first necessary condition is the sufficient warm SST, means your sea surface temperature should be greater than 26.5 degrees Celsius at least. And the sea surface temperature, not only at the surface, it should be up to certain depth, that is the 50-meter depth. So your the water column temperature should be greater than 26.5 degrees Celsius up to 50-meter depth. Next condition is atmospheric instability. Atmospheric instability means there is the temperature difference between lower level of the atmosphere and mid tropospheric level. So it should be exist. High humidity. So there should be the high humidity. The humidity should be around 50 to 60 percentage in lower to mid tropospheric. Sufficient Coriolis force. The sufficient Coriolis force is also one of the most important parameter for tropical cyclone formation. You know that the Coriolis force at the equator is 0. When you go up toward the pole, in both the pole, it start increasing. So due to this, the tropical cyclone cannot form over the equator. So it is normally form plus minus 5 degree away from the equator, where it gets the enough Coriolis force to rotate the wind. Pre-existing low level disturbance, that is also most of the important factor for tropical cyclone formation. Pre-existing low level disturbance is the main that is the seed of the tropical cyclone. Means there should be thunderstorm kind of activity should be pre-exist, because near the equator there is the trade wind. Due to the trade wind, the temperature of the air masses is different near the ITCZ, and due to the different air masses temperature, it forms the thunderstorm. Normally it forms and goes, but sometimes it organize into the long cluster, and it forms the tropical cyclone. And next condition is the low vertical wind shear. So wind shear also should be low, because the wind shear is the factor where the moisture supply cannot go reaches up to the higher level. So tropical cyclone cannot sustain for longer time. So vertical wind shear should be less. Vertical wind shear is mainly the wind speed and direction changes between the lower level at upper level. So it should be less than 10 meter per second. So this is the region where the tropical cyclone not formed during the monsoon season, because during the monsoon season wind shear is normally high over the Indian Ocean, over the North Indian Ocean. So it should be low. So the process of the tropical cyclone formations, we know that the high humidity and sea surface temperature are a major contributor factor for the tropical cyclone formation. When the low pressure forms, wind start moving from high to low pressure. Okay, and the water evaporates from the ocean surface and come into the contact into cold air up to the higher level. Due to the low temperature, it condenses, and then it forms it occurs the rain. When this process is continue, a column of low pressure form are developed at the center, and when the column of low pressure develop, the wind start moving around the low pressure area. When further this condition increase and pressure continuously decreasing, the wind speed is start increasing around the center. So this is the process for tropical cyclone formation. the energy potential from where tropical cyclone gets the energy, gets the energy. So mainly the tropical cyclone gets the energy from the warm water and humid air over the tropical ocean. When the ocean is warm and humid, the evaporation start, vapors goes upward, and at the upper level, due to low temperature, it condenses and it forms, it converted into water droplet. When it condenses, it converted into water droplet. During the conversion of the water vapor to water droplet, it releases the latent heat. The latent heat is now then the latent heat is then converted into the kinetic energy. That is the main energy potential source of the tropical cyclone that maintain the cyclone circulation. So the whatever released energy from the condensation process, only 3% of the energy is used by the tropical cyclone to maintain the intensity. This slide shows the tropical cyclone structure, how the tropical cyclone vertical and horizontal structure is. From the horizontal and vertical cross section, you can see this is the vertical cross sections of the tropical cyclone, and this is the horizontal view of the tropical cyclone. In the center of the tropical cyclone, there is the eye, that is called the eye. Eye is what? Eye is the central cloud-free region of calm wind. Means there is no cloud, no wind at the eye of the tropical cyclone. It can vary around 30 to 50 kilometer in diameter. The eye is the area where the lowest surface pressure and warmest temperature exist. So at the eye of the tropical cyclone, pressure will be low and temperature will be high. If you go further from outside, from center to outside, there is the deep convective cloud, a wall of deep convective cloud that is called the eye wall. So surrounding the eye, a wall of dense convective cloud, it rises up to 10 to 12 kilometer into the atmosphere. So that is called the eye wall. So this is the area where highest surface wind and maximum intensity of rainfall exist. So in eye wall region, the surface wind, maximum surface wind exists, and rainfall intensity also is high. If you go further toward the outside from the center of the tropical cyclone, you can see the spiral band kind of structure. That is the convection into the TC organized into long, narrow rain band, which are orientated in the same direction as the horizontal wind. Because these wind seems to be the spiral into the tropical cyclone, that's why it is called the spiral band. So spiral band also it is called the rain band. So it is often extend up to the 1,000 kilometer. So this is all about the structure of the tropical cyclone. Now coming to the how tropical cyclone gets their name. Whenever the any cyclone form in any region, normally you used to hear about the name of the tropical cyclone. Why it is required? Why it is important? It is important because whenever tropical cyclone form in different ways simultaneously, so if the regional meteorological agency is giving the forecast, the common people cannot understand without the name, means for what or for which cyclone this forecast is provided. So to understand, to make the to understand to the common people, that name is required. When the name is started, names were started first after the word was second, and then subsequently it is adopted by all the region. The most region predefined alphabetically list alternately male or female name. It is based on the male or female name. But over the North Indian Ocean, the majority of the name used are not personal name. That is the based on the flower, animal, bird, tree, or foods. So they do not use the personal name. And also the North Indian Ocean has started the namings from the October 2004. Before that, they do not give the name. So one super cyclone which is formed in 1999, the name was the Odisha super cyclone. Normally the name is given based on the where it is made the landfall. That kind of nomenclature it is provided. So after 2004, the naming has started and they usually give the name. But the question is how they decided the name and who decided the name. In the North Indian Ocean, mainly it is decided by the neighborhood country. There is the neighborhood country around the India. They each year they contribute the name. They give the list of the name in each year, and from the list one by one the name is used. For example, if the name this any particular cyclone, the name has given by the India, next time the name will be taken from the from other country. So once the name is used by any country, next will be the next will be the next country. So you can also find if you do the Google, you can also find the upcoming cyclone names, which is already decided and it is given. So you have seen that in the northern hemisphere, tropical cyclone rotate, the wind rotate in anti-clockwise rotation. What is the reason for anti-clockwise rotating wind? The main reason is the Coriolis force, which is responsible for the anti-clockwise rotation. If you look at this picture, this is the area of low pressure, and this is the high pressure. When high pressure and low pressure, the wind movement mainly will be the high, from high to low. And the differences of the pressure is called as the pressure gradient force. And the when the wind moves from high to low, this is due to the pressure gradient force. And the Coriolis force, what is the Coriolis force? Coriolis force is the apparent force which is acted by the any moving object on the Earth surface. So object deflected to the right in the northern hemisphere due to Coriolis force and object deflected to the left in the southern hemisphere. So these are the property of the Coriolis force. If you look at that, when the wind is moving from high to low and at the same time Coriolis force is also acting on that wind, it try to pulls the wind in the right directions and the resulting path will be your this one, this black curve. And the wind over this region, the due to the pressure gradient, wind movement from this direction to this direction, and the wind due to the Coriolis force, it pulls in the right direction, and resulting path will be this. So the wind started from anti-clockwise. So mainly the anti-clockwise rotation of the wind is due to the Coriolis force. So when the tropical cyclone form over the ocean, they do follow some certain path, but it is not follow the particular path. Sometimes it will suddenly change the path and it recurve also very sharply. But normally, when the other factor is not contribute, normally the movement of the tropical cyclone is based on the global wind pattern. If you look at this wind pattern over the globe, this is the ITCZ, and this is the tropical easterly. In the tropical region, wind move from east to west, because this is the high pressure, this is the low pressure, so wind move from high to low. Due to this, it will move from east to west. This is the subpolar low. So in 30-degree north to 60-degree north and 30-degree south to 60-degree south, wind move from west to east, that is the westerly wind. When any tropical cyclone form in the tropical region under the influence of the easterly, it start moving in the westward direction. In the presence of Coriolis force, which become gradually stronger at higher latitude, tropical cyclone started poleward movement. When it reaches up to 5 degree away from the 5 degree north or 5 degree south, the Coriolis force start acting and it try to pull the wind in the right direction. Due to this, the tropical cyclone path will follow the toward the poleward. But it is not always true. But sometimes what is the atmospheric condition suddenly change. Maybe the some of the studies says that the steering flow is also most of the important part for the tropical cyclone movement, where the when the steering flow is the mainly the mean wind flow of the atmosphere, which is responsible for the movement of the tropical cyclone. So other factor also is responsible for the movement of the tropical cyclone. But this is the general view. Now coming to the landfall, what is the landfall event? Where what is the this is the most important, because whenever tropical cyclone in the sea, people doesn't care about that. But when the tropical cyclone coming to the land, people are more curious. Common people want to know where tropical cyclone is going to hit. So landfall, there is the confusion in the common people. What is the means landfall is the landfall position. For the tropical cyclone, the landfall event is tropical cyclone coming onto the land after being the water. Here we have shown two pictures of the tropical cyclone. This is the Indian coastline. You can see the eye of the tropical cyclone is away from the coast, and here the eye of the tropical cyclone is inside the or at the coastline. So in these two scenarios, the landfall, we cannot say in this below picture, we cannot say the tropical cyclone has made the landfall. We can only say the tropical cyclone had made the landfall when the eye hit the coast. So however, the most of the part of the tropical cyclone, even though the most of the part of the tropical cyclone inside the land, we cannot say the tropical cyclone has made the landfall. We can only say the landfall event when the eye hit the coast. So when the landfall happen, what will be the impact due to the tropical cyclone? So because the tropical cyclone associated with the strong wind, storm surge, and heavy rainfall. Due to the strong wind, there is the damage of structure, loss of power and communication, loss of life and injury, generation of devastating storm surge, and destruction of vegetation and crops. So due to the strong wind, there are so many things can be happen. And due to the storm surge, there is the flooding of the coastal area, erosion of the beaches, loss of the soil fertility, some saline water, loss of the life, damage of the structure. So these are the major factors due to the storm surge. Due to the heavy rainfall, it can be a loss of life, destruction of the vegetation and crops, contamination of water supply, land subsidence, and flooding of land area. So due to the heavy rain, these many things can be happen. Now coming to the prediction of the tropical cyclone, because the prediction of the tropical cyclone is not only the track prediction. It consists of many parts. It starts from the low pressure itself, when the low pressure forms. So first thing is, when the low pressure form, there can be prediction of the cyclogenesis prediction. Cyclogenesis is what? Cyclogenesis is the formation of the tropical cyclone. At the stage of low pressure, we can predict the possibility of that low pressure. So this low pressure is going to develop into the tropical cyclone. So it will be developed into the tropical cyclone. So that kind of predictions lies in the cyclogenesis prediction. When the tropical cyclone is formed, it comes to the track prediction, where tropical cyclone is moving or where it is going to hit. And with the track prediction, there is the intensity prediction. It means what is the maximum wind of the tropical cyclone, because wind is the major factor which is destructing all so many things over the land. And when the tropical cyclone coming to the land part, the landfall prediction is also one of the most important thing. The landfall location and time, both information are very much important for the common people. And then when the landfall happen, storm surge prediction, how much storm surge has happened. And then after the storm surge, how much damage will be happen. So damage prediction is also one of the important prediction as in the tropical cyclone prediction. So these are so many part of the prediction of the tropical cyclone, not only the track prediction. So observations over the tropical cyclone. What observations we have to monitor the tropical cyclone? We have the ship measurement, where we take the ship into the ocean, and along the ship we measure the ocean and atmospheric conditions along the ship track. Another is the buoy measurement. Buoy is the instrument which installed into the ocean, and that gives the information about the sea surface temperature, salinity, and other oceanic parameter. Land-based observations. Land-based observation is your AWS and radar and all those things is very much important when the tropical cyclone is close to the coast. Aircraft measurement is also one of the most important observations over the tropical cyclone, where pilot take the aircraft into the tropical cyclone eye and measure the structure and the wind intensity near the center of the tropical cyclone. And the most important is the satellite, because these all observations when the tropical cyclone coming to the coast, these all observation is only the radar observation can give some information, but other observation maybe not available. And that also this is the point-based observations. It is giving the information at particular location, not spatially. But if you want to do the monitoring continuously or do the predictions, you have to get the information spatially, because the tropical cyclone extent is around 100 to 1000 kilometers. So in that case, that satellite plays a major role. So because the tropical cyclone, most of the lifespan is away from the land, and it is mainly formed over the ocean, and most of the lifespan is in ocean only. So that time the satellite plays a major role for the monitoring and prediction. So why when they are in middle of the ocean, there is worldwide that satellite which has launched by many of the country. You can see a number of satellite which is available in the space, which continuously monitoring the weather system and Earth from the space. So you can see a number of satellite has been present, which is continuously monitoring the our atmosphere. Over the India has also done the meteorological satellite mission. The first mission is the Kalpana one, which is launched in 2002, which are giving the informations about that cloud motion vector from the Kalpana observations, that it has been derived the cloud motion vector, outgoing long wave radiation, and rainfall informations. And then 2003 INSIT 3A launch, which is giving the information about the cloud motion vector, OLR, rainfall, and aerosol information. And 2013 and 2016, INSET 3D and 3DR has launched. There is a 6-channel imager, and 18-channel sounder is there, and one visual sounder, visual channel. So based on 6 channel and 19 channel of sounder and one visual channel is available. Based on that, they are giving the vertical profile of the atmosphere. That is important to continuous monitoring of the tropical cyclone, because these satellite INSET 3D and 3D are the geostationary platform which can continuously monitor the atmosphere and Earth. And another is the OceanSat 1 and 2 and SCATSat, which launched in 1999, 2009, and 2016. It giving the information. This is the SCATSat is the scatterometer wind is there. So SCATSat is giving the wind information over the ocean. And that ROSA is the radio occultation and observations also we get from the OceanSat and SCATSat satellite. Another mission is Megatropics. Megatropics is also one of the important missions done by the ISRO, which is giving the information over the tropical region. There is the microwave imager, microwave sounder, and scrab sensor, which is giving the information about the sea surface wind, TWV, rainfall, temperature and humidity profile, and radiation bezel. So from the satellite imager channel, how you can identify the cyclone structure and feature, because that imager channel is infrared, water vapor, and visual. In infrared channel, it measure the cloud top temperature, because it measure the heat radiation. Okay, so it doesn't measure the reflected light of the sun. When the light fall over the cloud, that it store the energy and then it re-emit. When the emitted radiation is observed by the sensor, and it is giving the cloud top temperature. So because over the tropical cyclone, it is deep convective cloud. So this is mainly appear as the cold temperature, because there is a lot of water droplet in the most of part of the tropical cyclone. So due to that, it appears the low temperature, low cloud top temperature. So satellite image not only show the storm location, but also can use to estimate the intensity. That also we'll discuss in next slide, how the tropical satellite image can be used to predict the intensity of the tropical cyclone. Then visual channel, we have visual channel. In the visual channel, you can see that it is measured, because when the sunlight fall over the cloudy region or Earth surface, the reflected sunlight is measured by the sensor, and it is available only the daytime, because the sun is when the sun is present in daytime, then only we sensor is recorded the reflected light. So during the daytime it is very useful, the visible channel, but night time we cannot find out any observation through the visible channel. And in the visible channel, because the cloud, the albedo of cloud is very high, because due to the water droplet, the albedo of the cloud is very high, and due to the high albedo, that reflectivity is very high, so it appears the bright in the visible channel over the cyclone location. Water vapor channel indicates mainly how much moisture is present in the upper troposphere. So it is useful for indicating where heavy rain is possible. So these channel are very important: infrared, visible, and water vapor for tropical cyclone monitoring. So these animation you can see, this is the insert 3D channel, the infrared channel, insert 3D visual channel, and water vapor channel. So you can see this is observations for super cyclone Amphan, which formed in the year 2020 and which hit the coast, West Bengal coast. You can see using the infrared, visible, and water vapor channel how you can monitor that tropical cyclone. In the visible channel, you can see in the night time, no observations available over the tropical cyclone, but during the daytime, very well cyclone structure you can find in the visible channel. So satellite-based monitoring of the tropical cyclone over North Indian Ocean, we have insert 3D 3DR. Using the both, we can find out the 15-minute observation. Every 15-minute interval, we can get the information. We have the SCATSAT. SCATSAT is giving the wind information over the ocean. This is the insert 3D 3D are the geostationary satellite, and SCATSAT is the polar satellite. So it moves around pole to pole. You can see in this animation that polar satellite moves around pole to pole. So due to this, it gives the observations twice in a day over the inner region. And that Saphir megatropics observation, you can see in the megatropics, one of the sensor name is called Saphir, which is giving the temperature and humidity profile of the atmosphere. There is a 6 channel which are giving the observation at different layer of the atmosphere. So it is giving the vertical profile of the atmosphere, which is very important for the tropical cyclone. And you can see in a day, 14 to 15 passes are available over our Indian region. The 3 to 4 passes we can get. So this is the picture taken by the Saphir sensor from megatropics. You can see this is the one cyclone formed over the Bay of Bengal region, that is called the Fani in 2019. You can see how nicely captured by the Saphir sensor. You can see this is the low temperature. You can see this color bar. This color is the low temperature, and this is the high temperature. So this shows that here is the deep convective cloud is available near the tropical cyclone, so where the low temperature has been observed. So very nice structure of the tropical cyclone can be found from the Saphir channel. And outer part of the tropical cyclone is also well captured by the Saphir sensor. You can see in this area. Now coming to the cyclogenesis predictions, because as I told that in the previous slide, cyclogenesis is the formation of the tropical cyclone, means the prediction of the tropical cyclone formation, that is the cyclogenesis prediction. So using the scatterometer wind, a method has been developed to predict the cyclogenesis. So in this method, the scientists Neeru Jaiswal and CM Krishwal from SAC, they have developed the method to predict the cyclogenesis using the scatterometer wind. In this method, what they have done, they have taken the data. This is the flow chart of that algorithm. They have made the database. For the database preparations, they have collected the cyclonic scene from 2000 to 2008, because this is the polar satellite, so it gives the two passes over this region. So it is the observation is not available continuously, so whatever passes available over the cyclone location, so that passes they have collected. And also, because sometime it covers partially, not fully, so for that they have discarded the scene. They have discarded that scene which is less than 60% coverage. So they have considered only the coverage is greater than 60%. If the 60% coverage is available, that scene they have taken, and they have not taken all passes. They have taken only some box around the center of the cyclone. So they block the size. The box size was 31 cross 31. This quick scat, because the OSCAT, the scatterometer satellite has launched in 2000. OceanSat 2 has launched in 2009. So before that, the observation was not available. So they have taken the scatterometer wind from quick scat satellite, which is not the Indian mission. But the principle is same. They are giving the informations as similar as the OSCAT 2. So the database has been prepared based on the quick-scat images, and all those database they have around 133 scenes they have found between 2000 to 2008, and they have stored these all data set. Whenever in real time any tropical cyclone form, this has been applied for the scatterometer wind. So they have collected this wind field over this box 31 cross 31, and whenever the tropical cyclone form, they took the real wind pattern of the scatterometer wind from Indian mission, and they try to match. They try to do the pattern matching from the database and the real scenario. So for matching, they have used this formula, and they have computed the matching index between two scenes, between the database and real, and the matching index, and they have found the matching index if it is greater than 0.6. For that, they have set the threshold. If the matching index is greater than 0.6, means this system or this low pressure is definitely going to develop into the tropical cyclone in coming hour or few days. So they are able to predict the cyclogenesis before the tropical cyclone formation. So for the matching, you can see this is the animations. From animation, it will be clear how the matching has been done. The matching has been done each pixels, and each pixels they have computed the matching index. They have computed the matching index, and where the matching index has found maximum, that matching index is considered as the center location of the tropical cyclone. So using this scheme, they have predicted so many cyclogenesis in real time. So during the Amphan cyclone, they have predicted this matching index. You can see here is 0.69, and this wind vector is from 15th May 2020. This Amphan cyclone has declared as a tropical cyclone on 16 May 12Z, 12 UTC. So before one day, they are able to predict this low pressure is definitely going to develop into the tropical cyclone. So it will not dissipate, it will intensify, and it will convert into the tropical cyclone. In the Nisarga cyclone, which is formed in the Arabian Sea in the same year, for the Nisarga also, they are able to predict this cyclogenesis before one day. This is the wind field for 1st June. The tropical cyclone has declared as that low pressure has declared as a tropical cyclone on 2nd June. 06 UTC. So this cyclone has predicted, this low pressure has predicted that this is going to convert into the tropical cyclone in after one day or few hours. So now coming to the center estimation of the tropical cyclone in using the infrared imager, because the center estimation is one of the most important part of the tropical cyclone. If you accurately predict the center, so you can able to predict the landfall location very accurately, and you can save the life and loss of the property. So this is also the methodology has developed by the Neeraj Jaiswal and CM Krishtwal. So this is the flow chart of that methodology. The basis of this technique is to determine the point around which the flux of the gradient vector of the brightness temperature are converging. So in this method, so first they have collected the images of the infrared channel. So this image, for the example, it is showing for the Kalpana image, but it can be applied for inside 3D and 3DR also. So this in this infrared image, they have taken the size of 401 to 401 tops, grid points. So around this central region, so they have not taken all images. They have taken around the center. They have cropped the images and they have computed the variance. So after that, the variance they have computed. After that, the flux of the gradient of the vector at each pixel they have computed. Okay, so the flux of the gradient of the variance of at each pixels over this domain they have computed, and then density matrix they have find out. So in order to compute the density matrix, what they have done, they have computed the flux of the gradient vector. Each pixel is drawn across the image, and the location where these lines are intersect each other is stored in a density matrix, and the score value of accumulated in the density matrix are averaged, and location with the highest score is identified. So this position is considered as the central location of the tropical cyclone. So you can see in the density matrix, the parallel line has been drawn, and where the intersection of the parallel line they have taken as the density matrix. So you can see over this line, the most of the parallel line is crossing over this point. So this point they have taken as they have identified the center of the tropical cyclone. So this method has developed, and using this method, the real time they are predicting the center of the tropical cyclone using the infrared image. So the center of the tropical cyclone of supercyclone of Amphan has been predicted using the scheme. So you can see this, the center position is very accurately they have captured by using this scheme. Now coming to the intensity predictions, the tropical cyclone intensity estimation using the advanced Dirac technique. So the intensity prediction is the one of the challenging tasks for the tropical cyclone prediction, because for the prediction normally we use the models, some numerical models. So numerical model is not that much accurate for intensity prediction. So using the satellite image, the one of the only technique is the Dirac technique. So using the Dirac technique, we can predict the intensity of the tropical cyclone. In the advanced Dirac technique, they have considered the cloud pattern. They are using the cloud pattern. So they have divided the images based on the cloud pattern in four categories. First is the curve band pattern. In the initial formation stage, when the that cloud is organizing, that is the curve band pattern. Shear band pattern is the formative stage of the cloud, or dissipation during the dissipation of the tropical cyclone. So this type of pattern can be observed where the cloud, you can see the cloud is one side of the center of the cyclone is moving. So that feature is recognized as the shear pattern. Now coming to the central dense overcast pattern. In central dense overcast pattern is when the eye wall is forming. So that feature is that center dense overcast. And eye pattern when the eye is very clearly visible. So they have divided this cloud pattern into the four category. Based on that, they are trying to compute the intensity. So the advanced Dirac technique is purely objective tool to estimate the tropical cyclone intensity using geostationary satellite. It is useful when the aircraft and any other data is not available. So to compute the intensity, there is a empirical relation. They have given the T number. T number. This is the flow chart of the intensity estimation. First, locating the cyclone, estimate the intensity. So to estimate the intensity, they have used this pattern to identify the intensity. And based on the intensity, like if you see the pre-storm, tropical depression, tropical storm, and hurricane stage, you can see they have given the some T number, where one T number is the unit represent the tropical, the typical one-day intensity change based on the climatological data. So each T number, they have computed empirical relationship between T number and intensity. If T number is 1.0, so intensity will be 25. If T number is 1.5, intensity is 25. If T number is 2.5, then intensity will be 35 knots. So based on this empirical relationship, they able to predict, this scheme is able to predict the intensity of the tropical cyclone. And nowadays this scheme are in use for predicting the intensity in real time. And for the track prediction, the spectrometer wind also, because using the satellite, we can monitor the tropical cyclone. We cannot predict the track 2 days or 4 days ahead in the future. So using the satellite, we can do the some nowcasting kind of thing. But if you want to predict the tropical cyclone track, you have to use some model, some numerical model. So how the satellite data plays the important role in the numerical weather prediction model? So numerical weather prediction model is basically set of some numerical equations which is describe the atmospheric flow. So based on that, it predict the atmospheric condition. So in the numerical model, it is very important to accurately compute the current atmospheric conditions. So to estimate the current atmospheric conditions, satellite data plays a major role. So in the model, they use the data assimilation technique. That in using the data assimilation technique, they inject the satellite into the numerical model to improve the forecasting. So many satellite can be assimilated into the numerical model. So some of the model you can I can name like global forecast system model, WRF model, and so many other numerical model is also exist. In that numerical model, we can assimilate the number of satellite data into the model, and we can improve the forecasting. So we have done some study using the spectrometer wind. We have assimilated the spectrometer wind in the numerical model, and we have found that because this spectrometer SCATSat wind SCATSat 1 satellite has landed in 2016. So we have analyzed the data during the 2016. Three cyclone we have chosen, that Kyan cyclone, Nada, and Vardar. And for this, we have done the impact study of this spectrometer wind. When we have assimilated this spectrometer wind during this cyclone period, we have found that we can see the wind field during 25th October for Kyan cyclone. The wind field has modified over the cyclone location. So we have observed that the improvement, and when the wind field has modified and your initial conditions and current atmospheric condition of the model has improved, definitely your track will be improved. So after improving the initial condition using this SCATSat data, we have found that the track of the tropical cyclone, you can see the blue track. Blue track is the control run where the no spectrometer wind has applied, and the red is when we have applied the spectrometer wind from the SCATSat 1. So when we have assimilated the spectrometer wind, we have found that significant improvement can be observed in the track. Okay, so based on the average error of three cyclones, it has been observed that except Nada cyclone, because Nada cyclone lifespan is very less, and because this is the polar satellite, and sometime observation was not available during that cyclone. So except that Nada cyclone, we have found that the track has got improved for other two cyclones. And it is also had found that the mean absolute error of the intensity forecast is also got improved. So we can use this satellite data to improving the forecast also from the numerical weather prediction model. So this is the last slide of my today's talk. This is the site where that Scorpio site you can see, and the MOSDEC, where that SAC Space Application Center ISRO are providing the real-time information about the tropical cyclone, about the center of the tropical cyclone, track of the tropical cyclone, intensity, cyclogenesis predictions, all are available in real time. This is the www.mosdec.gov.in /Scorpio. Scorpio, this is the full name of the satellite-based cyclone observations for real-time prediction over Indian Ocean. So you can find all the forecasts on this website. I want to show that website. You can see this is the mosdec.gov.in /Scorpio. So if you click here, you can find the archive also, like 2021. In for each cyclone, there will be the archive. You want to find out the intensity or cyclonic center, you can find the center identified center using the satellite images. And if you want to find the track information is also available over the archive and real time also, because this time that tropical cyclone is not formed, that's why there is no track can be seen on this map. But during the cyclonic season, you can see if any cyclone formed, the real time the prediction has been given. So track also for any cyclone you can find, like Toktek cyclone. If you see track, that archive also you can find the track forecast. So this is the website. developed by the SAC ISRO. You can visit this website and you can find the forecast. Thank you. Thank you for your attention.